Welcome back. Sorry for that. We had to take a quick little pause while we changed out some technology stuff. You know, technology sometimes doesn't agree with us. So we are back. We just left off with checking 3 times 6. We said that was a factor of 18, 3 times 6. We checked 5, but 18 doesn't end in a 0 or a 5, so 5 is not a factor. So the next factor I would check is 6. So I'm going to ask myself, is 6 a factor of 18? What does my class think? Is 6 a factor of 18? Yes, it is, because I can count 6, 12, 18, or I can check it's already has a factor of 3 and a factor of 2, so that means it automatically has a factor of 6. But also, I've already got 6 here. So what does that mean I write down in my list? I don't write anything because I already have 3 times 6, so I'm not going to write it again. So my final answer, all the factors of 18 are 1, 2, 3, 6, 9, 18.
Yeah, I got it right. Ooh, not bad.
All right, obviously we're getting pretty good with our factors.
Yes.
All right, guys, we're going to bring it back. Thank you, and we're going to keep going. Number 7. Go on down to number 7. We're going to ask ourselves, which factors do 32 and 48 have in common? So I'm going to do my factor lists for 32 and 48, and then I'm going to compare them. So first I'm going to do 32. Now I'm going to go through this just for the essence of time. What I do is challenge you right now to answer this at home and then see if your numbers match mine. So I'm going to start with 1 times 32. I'm going to move to 2. Well, 32 is even, so 2 is a factor. 2 times 16 is 32. 3 plus 2 is 5, which is not a multiple of 3. So 3 is not going to be a factor. 4 times 8, 32. 32 does not end in a 5 or a 0, so 5 is not a factor. And then I get to 6. Well, 32 has 2 as a factor, but it does not have 3 as a factor. So that means 6 is not going to be a factor. 2 and 3 both have to be factors for 6 to count as a factor, but it doesn't here. So then I go on to 7. Is 7 a factor of 32? Yes?
No.
Nope. And what about 8? Is 8 a factor of 32? What do you think?
Yes, because 4 times 8 is a factor.
Good. 4 times 8 is a factor. That means 8 is a factor of 32. But do I write it on my list?
No.
No. Nope, because I already have it. So now I'm going to do 48. 1 times 48. You at home should have already done it, so check your factors. 2 times 24. 3 times 13. What is it? Times 13? 4 times 12. No, not 3 times 13, 3 times 16.
Because 3 is a prime number.
Exactly. So 3 times 6 is 8, carry the 1, 3 times 3 is, 3 times 1 is 3, plus 1 is 4. So 16, 4 times 12, does not end in a 5 or a 0, so 5 is not a factor. 6, well, it has a 2 and a 3, so that means if it has a 2 and a 3, 6 is a factor. 6 times 8 is 48. 7, well, I know 7 times 7 is 49, and that's too close to 48. So 7 is not going to be a factor, and then the next one I would check is 8, and that one's already right here. So now I'm going to stop, and I am going to compare my answer choices. So we have 1 is on both lists, 2 is on both lists, 4 is on both, 8 is on both, 16, and that is it. So I'm going to look at my list, and I'm going to circle 1, 2, 4, 8. And those are my answers for my multiples of 32 and 48 that are in common. Moving down, select all the numbers between 50 and 70 that have exactly 4 factors. So for 50, I am going to do 1 times 50. It ends in a 0, so that's 2 times 25, 5 times 10, 10 times 5. There are a lot of options. Now I've already gotten to 3-factor pairs, which is 6 factors, and I only wanted 4. So 50 is not an option. Now I'm going to move on. 55. I can do 55 times 1 and 5 times 11. But there are no other factors that would equal 55. So that's one of my answers. Then I do 60. 60 times 1, 30 times 2, 10 times 3, and I could keep going, but I already have 3 pairs, which is 6 factors, and I only want 4. I want exactly 4. So 60 is not my answer either. 65, I can do 1 times 65. It is not even, so I can't do 2. It does not add up to a multiple of 3, so I can't do 3. Can't be divided by 4. Can be divided by 5. So 5 times 13 is 65. Are there any other factors that I can multiply to get 65? Sure thing. I'm going to slow down just a little bit. If I'm going too fast for you at home, you can pause and watch it again and rewind. But in real life, I'm going to slow down for you guys. So 65, we did 1 times 65, but it's not even, it's not a multiple of 3, it's not a multiple of 4. So the only other factor we can get for it is 5. 5 times 13. There's nothing else. So that's exactly 1, 2, 3, 4 factors. So 65 is my second answer. And I'm going to check my last one, because like they reminded me, we check everything. So that's going to be 70 times 1, 35 times 2. Let's see, it can be divided by 10 times 7. 5 can go into this one, about 5 times 6, 5 times 16. 5 times 13 is 65, so 5 times 14. Well, there's already 8 factors. I want exactly 4. So that means my only answer choices are B and D for this one. Good job. Yes.
For 60, you actually put 10 times.
I did, and it should be 10 times 6. Good catch. All right, which of the following numbers are multiples of 4? Select all. Well, our multiples are the skip counting. That's when we skip count or calculate each of the products we can get. So it's going to be 4, 8, 12, 16, 20, 24, 28, and we're going to keep going. If I write out or list out in my head all of my multiples of 4, I'm going to notice my my multiples are 12, 20, and 28. Those are my 3 correct answers. Yes. I only want the ones that I get when I skip count by 4. Now for number 10, we know 6 times 8. All right, we're back. We had to pause for a second because there were some announcements going on. Gotta love when we're doing this live in class. It keeps it interesting. But now we're back. So we just started moving on to number 10. We know that 6 times 8 equals 48. So which of the following statements is also true? Select all. Well, in this case, this is where factor times factor equals multiple can help me a ton. If I look here, I can see, well, 6 is a factor of 48. If I write out 6 times 8, equals 48, 6 is a factor. So this is true. 48 is the multiple of these two factors. So 48 is a multiple of 8. 6 is a multiple of 48. Well, that would mean that I would be skip counting by 48 to get even bigger and bigger and bigger. But if I do that, I'm never going to get to 6. 6 is not a multiple of 48. So this one is not true. 48 is a factor of 6. Well, this would be saying that 48 times something could equal 6.
Nope.
No, that doesn't make sense either.
That's impossible.
So,
C.
exactly, C and D are kind of saying the same things. But our only two accurate true answers are A and B. Alright, we're doing really good in this class. Let's keep it up. Alright, we're going to skip to the last page because these are some important word problems we're going to go over. Alright, so number 16. Mrs. Foster ordered 2 boxes of magnets for an experiment. Each box had 20 magnets. There will be 8 students in the lab group. Which equation can we use to find the number of magnets each student gets if they are divided equally? So for this question, we break it down one step at a time. The first thing I'm going to do is read my first sentence. Mrs. Foster ordered 2 boxes of magnets for an experiment, and each box had 20 magnets. So if that's where the question stopped, and that's all I gave you, how would you write an equation to express that piece of it only?
2 times 20.
2 times 20. 2 boxes times the 20 marbles in each box. Awesome. Now, once she does that though, then Miss Foster has to decide how many marbles each of the 8 students is going to get. And she already said she's going to divide them equally. So what would be your next step for this situation? Well, we would, but right now we're just first doing an equation. So I'm not going to calculate anything yet. I want to figure out what my next step in the equation would be. 2 times 20 is going to tell me how many magnets I have. But then what do I do with that group of magnets?
How you divide it?
Divide it by what? By the 8 students. Good. So if I do 2 times 20 and then divide it by 8 like you just said, that's going to tell me how many magnets each student gets. So which answer choice is correct? A. 2 times 20 divided by 8 equals M. Now the major key to remember here is a lot of these look very similar, so you have to read your symbols carefully. Yes, ma'am.
Yeah, because each doesn't always make divides.
Good, exactly. Yes, ma'am.
And but B, it has a plus sign.
Yeah, B has a plus sign. We know that our operations are multiplication because of our words each. And then we're dividing it into groups, so that's division. So I need to have both symbols.
And
Next, number 17. Miss W is shopping for lunch boxes that cost $18 each. She writes the following equation to represent the situation. What does the number 10 represent in the equation below? Well, in this situation, Miss W starts with $18, or $82. Miss W starts with $82. Then she decides she wants to buy backpacks or lunch boxes. I had typos, so they're the same thing, let's imagine, for $18 each. But we don't know how many she's going to buy yet, but we do know they're going to be $18 each. So she's going to take her $82 that she has to start and divide it by the cost of each backpack, $18, to figure out how many backpacks she can buy. So if her answer is 4, remainder 10, what does the 4 represent? What do you think the 4 represents?
Like 400.
Well, the remainder is the 10 part, but right now we're just talking about 4. What is the 4 in this situation, we'll call it? No, I'm not checking it yet. I just want to know, like, in real life, the 82 represents the money she has to start. The 18 represents how much each backpack costs. So what does the 4 represent?
I think it represents how many backpacks I bought.
Beautiful. So if she's dividing her $82 by the amount each one costs, she can afford 4 backpacks. But then she has a remainder of 10. So what does that remainder of 10 represent?
What you're gonna add together to get your answer. And
Not quite. That's if we were checking it. We're not checking yet. I just want to know if we figured out she can buy 4 backpacks with her money, but she has a remainder of 10. What does that remainder of 10 represent?
Leftover.
Leftover what, lunch?
Leftover after he purchased the 4 backpacks.
So how many backpacks are left over in the store after he buys them? Or she? Thank you. He said a keyword leftover. Who can build off of that?
Well, since like you just said, it's kind of like 4 times 10 because it's 40.
Let's see. The 4 represents how many backpacks he can afford, she can afford. But then she has a remainder of 10. Leftover 10 of what? $10. She has $82. She divides it by how much each backpack is. So each backpack or lunchbox is $18. That means she can afford 4 backpacks. And then she has $10 left over after that. Yeah. Happens. All right, and the last question we have just enough time for. Miss Nick and her friends bought 110 eggs. Because I wanted to bake cookies for you guys. But then we got hungry and we decided we were going to eat 60 of the eggs for breakfast. I know, I was hungry. So if I eat 60 eggs, what does that do to my number of eggs that I started with? How do I represent that in numbers?
You subtract 100 minus 60.
I take 60 eggs away. Great. That leaves me with 50 eggs. Then we are going to divide the eggs equally into 5 containers. So that means I'm going to divide my 50 eggs into 5 containers. 1, 2, 3, 4, 5. Well, if I'm dividing 50 by 5, how many eggs are going in each container? Well, I'm starting with 50, and then I'm breaking them up because I don't want to put them all in one container. So I'm going to break them up into 5 different containers. But I want to know how many can I fit in each container?
10.
10 eggs in each container. So 10 in this one, 10 in this one, 10 here, 10 here, and 10 here. So now I've put all my eggs in their containers. They're great. There's 10 in each one. And I go, hey, Natalie, can you go put this in the refrigerator until it's time to bake? She goes, sure. She picks them up. She carries them. But Natalie's clumsy. So Natalie trips and drops one of the containers. So that means one of my containers breaks and those eggs are gone. So now, once I throw away those eggs, if I use all the rest of these containers to bake my cookies, how many eggs were actually used for cookies? 40. 10, 20, 30, 40 eggs actually made it into the cookies. Because we're hungry and we're sloppy and unfortunately we didn't get any of our other eggs into the cookies. But we were able to keep 40 of them safe for the recipe. Alright, so we're going to stop there for today. Good luck reviewing all of this. I hope that it makes sense. If not, message me in the comments, and I'm going to try and get back to you with explanations, or ask me in class tomorrow. All right? Everyone say have a great night.